Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a question called largest sum cycle. So it is a Juspay related question. Okay, in first round, Juspay will ask this question in frequent manner. Either it is in second question or third question. Okay. Given a maze with n cells, each cell may have multiple entry points, but not more than one exit point. So which means one cell may have multiple incoming edges, but it only have one outgoing edges. That's what it means. Okay, because it is a mice and it is a group of cells, n cells. Okay, that is entry or exit points are unidirectional doors like valves. So it is like we can go to one node, but we cannot return back. So it is unidirectional. We can go only one side. Okay, if one is pointing to 2, then 2 cannot point to 1 in that edge alone. Can you understand this? I will clearly explain this. Okay, you are given an array edge of n integers where edge of I contains the cell number that can be reached from of cell I in one step. Edge of I is -1 if the ith cell doesn't have any exit. So it means we don't have any exit, then that edge of I is -1. If we have any exit, then edge of I will points to that. Okay, then the task is to find the largest sum of cycle in the maze. Sum of cycle is the sum of the cell indices of all cells present in that cycle. So first of all, what is meant by cycle? Cycle means if node is a starting point and somehow it is going and again it comes back to that node, then it is called a cycle. Okay, now note the cells are named with an integer value from 0 to n-1. So this is the key value. Now if there is no cycle in the graph, then we want to return -1. Okay, so here they have given some of our clues. Okay, the first clue is that they have multiple entry point but only one exit point. That's the first clue they have given. And also they have given that it will be reached in one step. So it is directly pointing. Okay, so it is a second clue. And the third clue is that here, so the value will be from 0 to n-1. So this is the third clue. So from this we can see how to derive the answer. Okay, before that we can see this test case. See here, n is equal to 4. So what are the possible nodes we can have? 0, 1, 2 and 3. Okay, now for edges 1, 2, 0, -1, it means what? It means that here it is 0, right? So 0 is pointing to 1, which means from 0 to 1 a edge is going. Okay, now here it is 2, which means from 1 to 2 one edge is going. Here it is 0, which means from 2 to 0 one edge is going. Here it is -1, which means what? They have clearly said if it is -1, there is no exit. Okay, fine. So see here, from 0 it is 1, from 1 it is 2, from 2 it is again 0. It is called a cycle. We know that, right? So a cycle is like a starting and the ending point is same node. Then it is a cycle. So what is the sum? Sum is 3. So we are returning a 3 because there is no more cycle. If there is any other cycle, we want to compare with that cycle and we want to give what is the maximum among them. Okay, and see this example here. There is no cycle formed because 1 is pointing to 0 and 0 is pointing to 2 and 3 is pointing to 2. So there is no cycle. So we want to return what? -1. Okay, let us understand how to do this. Okay, let us see this example. See here, this is the first example I have given. So how to just I am just again recapping once again. So 0, 1, 2, 3, 4, 5. First step, we want to construct a adjacency array, right? We want to understand how this adjacency list works. Okay, that's why I am telling again. So see here, it is 0, right? 0. So 0 is pointing to 1. This is the meaning. So 0 is pointing to 1. Now 1 is pointing to 2. 1 is pointing to 2. Same like 2 is pointing to 0. So 2 is pointing to 0. Now 3 is pointing to 4. 3 is pointing to 4 and 4 is pointing to 2 and 5 is also pointing to 2. Now hope you understand how this list work. Adjacency list, which is an array representation by which we are just visualizing our graph. Okay. Now coming to the logical part. Okay, fine. So here we are going to use a logic called topo sort. You may ask why we are going to use a topo sort. Because the topo sort is an algorithm which is used in order to just remove the unwanted nodes which doesn't have any in degree, and it is like we can know which node has a higher priority and which node has a lower priority by in degrees. Okay, so I will clearly explain this. So see here, first of all we are going to find how many incoming edges are for this individual nodes. Okay, first of all for 0, how many incoming edges? 1 incoming edges. Okay, for 1 it is 1 and for 2 it is 1 incoming edges. Okay, now for 3 it is 0 incoming edges. Okay, for 4 it is 1 incoming edges. Here also it is going to 2 and here also it is going to 2. So 2 totally have 3 incoming edges. Okay, now clearly understand we are going to use a topo sort. Okay, in this topo sort logic, first of all I want to remove the in degree which has 0. Okay, so this 3's in degree is 0, which means there is no node that is pointing towards 3. That indicates we cannot form cycle with this 3. See, if from this 0 to this 3, if I have a edge, then it forms a cycle. Maybe it forms a cycle. But you want to understand that this 3 doesn't have any incoming edges. So it means what? It means it doesn't have any like cycle can be formed. So I can remove this 3. Okay, what is the subsequence of removing this 3? If I remove this 3, this in degree will become 0. So obviously I want to remove this 4. If I remove this 4, what this 2 becomes? 2. Okay, then this 5's in degree is also 0 because it doesn't have any incoming edges. Delete it. Okay, delete it in sense, don't take it in the consideration. Okay, now this 2 becomes what? 1. Hope you understand this. Okay, any other? No, all having greater than 0. Now come and find what are the cycles are there in this graph. Okay, so here comes the clue number 1. What is that clue number 1? We may have multiple entry point, but we only have one exit point. That's the clue number 1, right? So for this topo sort, now we are using that clue and making this change. Yes, understood? Okay, fine. Now what is the next step I want to do? Okay, fine. Now the next step is to find the cycle. How to find the cycle? We may go for BFS or we may go for DFS. So I am going for a DFS. You may try this BFS. If you have any doubt, just give it in the comment section. I will make the individual video. Okay. Now let us go with the DFS solution. Depth first search. Now I will start from this 0. Okay. And I will take a visited set to ensure that whether it is visited already or not, because it is cycle, right? Cycle means we are just visiting again the visited node. That's the cycle. So first of all I am at this 0, right? So I will put this 0 into a visited set. Now I will move to 1 because after 0 is connected to 1, right? Okay, now this 1 will be added. Now again go to this 2. This 2 will be added. Again I will go to where? Go to 0. Sorry, it's 0. 0 is already in our set, which means I can say we cannot go apart that. We already has a cycle. It already has a cycle. So backtrack. While backtracking, just return from the 0. Just return here. I am 0. I am the node. Okay, you are visiting. So already visited, right? The 0 is already visited. So just I return 0 because it is already visited. It is already in the visited set. So return 0. Okay. From this 2, where I will backtrack to this 1. Again, to know about this graph question, your prerequisite is to know about more concept on backtracking. Just practice in backtracking, so that only you can go with the graph questions. Okay, now I will backtrack to this one by sending what? By sending, hey, I just called this 0 and it gave me 0. Now take my value 2, my value 2. So 2 plus 0, which is equal to 2. 2 will be sent to this node 1. Now this node 1 again backtracks and send what? Hey, my value is 1 and remaining node's value is what? 2 plus 0. So 2, which is equal to 3. I will send to 3. Okay. Again, it will backtracks and come to our function call. Come to our function call. So it is what? 3. So 3 is our answer. Hope you understand this. So it is only one cycle, right? We want to find in multiple cycles. So in this second example, I have taken nearly 2 cycles, I think so. We may do so that we can understand. So this is the array they have given, and I constructed a graph for a visualization. This graph is just for our visualization and solving. Okay, it is not the implementation. This is the implementation and this is the visualization, this graph. Okay, fine. So first step, what we want to do, we want to remove the nodes that are what? Or instead of remove, I can use a word. We want to not take the consideration of the nodes which have a in degree of 0 or no incoming edges. So I don't take this as our consideration and this as our consideration, this as our consideration. So this then, so if I delete this 0 or if I not take this 0 in my consideration, then this 5 will be what? Whether this 5 will be taken into not consideration? No, this 7 has a node, right? This 7 has a edge to 5. Okay, whether I can do anything, this 2 no, this 7 no. So that's all. We can take only these 3 nodes. Okay, so this is the first step. What is the second step we done in this above example? The second step is that we want to just move one by one, right? See here, what we have done here, just we have moved one by one and we are finding which has the largest cycle, largest sum cycle. Yes, so let us start. So I'm going to start from 0 first, but unfortunately 0 is what? Not considerable. Okay, so don't take it. Here 1, no, it is also not considerable. Actually in the above problem itself, we will after finishing this 2, we will take this 3 also. Okay, but it is not considerable. 4 also not considerable, 5 also not considerable. That's why I skipped. Okay, so here I mention this 0 and 1 as a doesn't have any incoming edges, because you want to know about we don't take that in our consideration. Okay, that's why when I'm just making a DFS call for this 0, I don't take the consideration. I will skip it. I will skip this 1 also. But whether I can skip this 2? No, we want to take it because it has a in degree, right? Okay, now from 2, where I will go? I will go to this 4. Okay, from 4, where will I go? So I want to take a visitor set. Okay, inside this visitor set, this 2 will be added. Now it goes to this 4 and 4 will be added. Again it goes to this 2. 2 is already in a visitor set. So what should I do? I should return what? 0. Why? Because hey, I am in the visitor set. Then why should I go further recursion call? I will return 0. That's it. Okay, from this 4, what will be returned? From this 4, backtracking, and what will be returned? It returns what? Hey, myself is 4 and my before values are 0, so which is equal to 4. That's it. Okay, 4. Now this 2 will returns what? Hey, myself it is 2 and other nodes are 4, so which is equal to 6. So 6 is my as of now answer. As of now, okay, because there is no more cycle in this 2 and 4, right? Now after 2, where I go? I will go for this 4, but 4 is already in the visitor set, so don't do anything. Now I will go for this 5. Okay, whether this 5 is in visitor set? No, so we can go. Yes, so I will take consideration. Now I will go to the 6, take consideration. Now go to the 7, take consideration. Now again go to this 5. What happens? Hey, already it is in the visited set. So what should I do? I should return 0. Okay, fine. Now from this 7, what will be written? Hey, myself 7 and other are 0. So 7 will be returned. Okay, from this 6, what will be written? Hey, myself 6 and it is 7. So which is equal to 13. So this 5 will return what? Hey, myself 5 and it is 13. So which is equal to 18. Can you understand this? So it is the exact working of our algorithm. This first one is partial, to understand partial concepts. Okay, and the second example is how exactly it works. Okay, so it returns 18. Already it is 6. 6 or 18 is maximum. 18 is maximum. So I will take this cycle. So this is the maximum sum cycle, right? So I will take this 18 as our answer. Hope you understand this, right? Okay, fine. Let us go for a coding path. So see here, this is the code. So first of all, I want to do what? I want to take the in order, in degree, right? In degree means what? How many edges are incoming? So I am taking in degree is equal to 0 into n. So I am taking a array or a list of filled with 0 up to n times. Okay, now for I in range of n, if edge of I is not equal to -1, let us take a dark theme. It is quite comfortable, right? Okay, now for I in range of n, so if edge of I is not equal to -1, which means what? Which means if it has a out degree, if the current edge has a out degree, then what should I do? I should take in degree of that value plus is equal to 1. So which means, just see here, this is what? 0. This is what? 0. And the 0 has what? 1. It is not equal to -1, right? So which means it has a out degree for which 1. For 1 it has a out degree. So for 1 I want to include what? +1 in degree, because from 0 to 1 there is a incoming edge. That's what. Okay, now this will be the process I will do for getting the in degrees. That means incoming edges. Okay, fine. Now q is equal to dq of, so I am taking a q data structure. Now for I in range of n, if in degree of I is equal to 0, which means what? Which means if a node doesn't have any incoming edges, then I want to do what? I want to take it into the queue. Okay, now while q node is equal to q dot pop left of, which means I'm just popping from that queue. Okay, and I want to take next is equal to edge of node, and if that current node which doesn't have incoming edges, see here, I will demonstrate it. If this is the case, okay, it doesn't have any incoming edges, right? It is 0. So this will be in queue. This will be in queue. If its next is what? This 2, and I want to take a 1 connection from this 2, and I want to check whether this 2 have any in degrees apart from this. No, it is 0, right? So I will take this in my queue, so that whatever thing it points, I want to check that whether it also satisfies the condition or not. Quite confusing, but just realize. Okay, fine. So that's what I am done here. Okay, fine. Now the next is not equal to -1, then in degree of next minus is equal to 1. Okay, if the next itself doesn't have any, it does have any incoming edges, then what should I do? I should -1 in that incoming edges. And if in degree of next is equal to 0, which means if I am just cutting out that node, if it make the next node to 0 incoming edges, then I want to cut that node also, right? That's why I'm just adding that into a queue. Okay, now visited is equal to set of. Then this is the DFS function. Let us see this so that we can understand what this is. Okay, now result is equal to -1 for I in range of n. If I is not in visited and also the incoming edges of that I is greater than 0. I here stands for node. Okay, now result is equal to maximum among the result comma DFS of I. So this DFS is to find the maximum cycle or a cycle sum. That's appropriate, a cycles sum. That's what this DFS of I returns. Okay, now result is as it is set to -1. If there is no cycle, then this -1 will be returned absolutely, right? Now def DFS of node, If node in visited, then what we do, we will return 0. Else what we do, we will add into our visited set. Then what we do, return node plus TFS of edge of node. So what it represent? It represent whenever I'm moving or backtracking, then I want to return what? Myself and what are all the node before me. Can I understand this? I will return that. So that's the thing I have done here. So this is the whole part of the code. Let me submit it. Yes, it is submitted successfully. Then I want to tell you a point of summarize. Before that, I will tell the time complexity will be O of n and space complexity will be O of n. Okay, because I am taking an in degree, right? And this time complexity because I am traversing. Okay, fine. I want to tell you the summarized point. So what is the first step I have done? The first step I have done is I am taking the in degree, which means I am taking the incoming edges. Okay. Then what is the second step I have done? I am just making, or I am just moving one by one and checking whether these in degrees, which in degrees is equal to 0, affects the next in degree. Okay. So I am using a Q data structure to just take, or just we want to take some note to the consideration, right? So unconsideration. So this is the second step I have done. So what is the third step? The third step is I want to traverse among all nodes and check for the cycle. And what is the fourth step? I want to take the maximum sum among the cycle, then return it. That's it. So these are the steps I want to do this in this question. So it is quite big question, but if you understand this logic and try it by yourself, then it becomes very, very easy. Okay. Thank you.